Hello everyone. Today we are going to discuss a very important topic of communication systems, that is modulation. Now what is communication? It is the transfer of information from one place to another. And modulation is a basic requirement to achieve this communication. In this episode of modulation, we are going to discuss what is modulation, that is the definition of modulation using its analogies, and why do we need modulation at all, that is the need of modulation, which will cover the size of the antenna, the multiplexing and narrowbanding. Now what is modulation? Now before going into the technical details of modulation, let us suppose the information which we are going to transmit is U. U are the information which is to be transmitted from one place, say from one country to another. So how that information is transmitted? Either you go by walking. Is it possible? It is possible, but it is not feasible. Why? Because you don't have that much strength, or you can say that much power. So what do? To overcome this weakness, you take up a carrier. Which type of carrier you can take? You can take either a bus, a train or a flight. Similarly, when we are transmitting the information signal, which is generally an audio signal, say a text signal or an image or a video signal, which lies in the frequency range of 20 Hz to 20 kHz, that is a low frequency signal. It cannot be transmitted as it is to long distances because it is weak. So it uses a high frequency carrier signal, like you were taking a bus, a train, a flight as a carrier. So this process of taking a carrier to take the information from one place to another is known as modulation. Thus, modulation is defined as a process in which the low frequency information signal is superimposed upon the high frequency carrier signal to get transmitted to another place. Let us take another example. Say you are throwing a paper from one apartment to other. If you throw the paper as it is, it may not reach to the destination because it does not have that much strength, that much power. But if the same paper is now wrapped in a stone which is having some weight, and now you throw that stone, that will reach to the destination. So here that stone is nothing but the carrier signal. So similarly in communication systems, we use a high frequency carrier signal to transmit the message signal, which is the low frequency. Now the question arises, what is the need of modulation or the advantages of modulation? So first and the foremost thing here is the size of the antenna. That is the practicability of the antenna, you can say. Now for transmitting the electromagnetic wave through free space, you need a transmitting and a receiving antenna. And for efficient transmission, the height of the antenna is given by a relation which is lambda by 4, where lambda here is the wavelength of the signal which is to be transmitted. Now for an audio frequency range of 20 to 20 kHz, using the relation C is equals to F lambda, where C is the velocity of light, we can see if we take F, say 30 Hz, the height of the antenna comes out to be 2500 kilometers. So it's not feasible to build an antenna of this much height. So if we go on increasing the frequency, let us see what happens. If we take F of 3 kHz, then the height drastically reduces to 25 kilometers. If we further increases the frequency to megahertz range, say for example 3 megahertz, that is 10 to the power 6 megahertz. So using the relation C equals to F lambda, getting the lambda, and H is equals to lambda by 4, you get H comes out to be 25 meters. So now the height comes to a feasible range. So it is practically possible to design an antenna of this much size. So here you can easily see the relation. As the frequency increases, the height of the antenna decreases. That means using modulation, you can achieve an practicability of the antenna. Another important need of modulation is multiplexing. Now what is multiplexing? It is a process in which two or more signals are transmitted over the same communication channel simultaneously. Now using modulation, what do? We assign different carriers to the different signals which are transmitted simultaneously. Now each is having a different carrier, so they are not getting mixed up. Without modulation, what happens? There may be a case when the signals are mixed up and there are interferences from one signal to another. For example, let us suppose there is a gate. Two persons are going from one side to other. If they are going at the same time, there may be a case they may collide. But if we assign the different path to different persons, say left person goes from left path and right person goes from right path, simultaneously there will be no collision. Similar is the case, like two persons are speaking at the same frequency simultaneously, there may be a case that the signals get mixed up and nothing is clearly audible. But if the same person speaks in a different frequency range, other person speaks in a low frequency or a different frequency range, then the chances of getting mixed up is minimal. Similar is the case with the transmission of multiplexing signals. Like in TV, you can see different signals are coming at the same time, but they are using different carriers, so they are not getting mixed up. This is the major advantage of using modulation. The third need of modulation is narrowbanding. Now what is narrowbanding? Modulation here helps in converting a wide band ratio signal into a narrow band ratio signal, which is termed as narrowbanding. Now what is a wide band ratio signal and narrow band ratio signal? Let us take an example. You're transmitting an audio signal having the frequency component from 50 Hz to 1 kHz. Now to cater to 50 Hz you need a big antenna. To cater to 1 kHz you need a smaller antenna. That means now the antenna has to be designed very appropriately using these extreme requirements. So it may be the case that to achieve a ratio of 20 Hz, the antenna may not serve the purpose. But when you modulate the signal using a high frequency, say 1 MHz, now your components of highest and lowest frequency becomes approximately unity. That means the same antenna can be designed for transmitting the low frequency component and for transmitting the high frequency, because now they both are being shifted to the high frequency. Now the ratio becomes only unity, so antenna can be properly designed without the extreme requirements, and thus a wide band ratio signals comes down into the narrow band ratio signal, and that is known as narrowbanding, which is achieved using modulation. So these are the three important needs of modulation which we have discussed today. In the next episode of modulation, we will discuss what are the different types depending upon the different types of signals and different types of carriers used, and how do we represent the signal mathematically. That is the time domain representation and the frequency domain representations. Thank you.